Hello all, welcome to my channel SPS Physics Classes by S. Panindra Sharma. Today, let us try to see the concept of vertical circular motion. In the vertical circular motion, how can you find the results and what are the important topics that you have to remember? We will see one by one. The concept of vertical circular motion. In the vertical circular motion, we have two types of situations. Number one, first situation is nothing but uniform circular motion. Under uniform circular motion, what we have to be take care? While the object of having mass m, if it is allowed to rotate in the circular track, this particular circular track contains a radius of say r. Radius of system is r and mass is nothing but m. If the system is allowed to rotate in the particular track, then what will happen? So exactly when the system is at the top point, means here, goes like up to here. Then when you try to prepare the tension condition, tension at the uppermost point in this particular cable, this is called tension T. Whenever the object is rotating, tension is directed towards the point of suspension. T always directed like this. Therefore tension at the upper point T is equal to, we can write down as mv square by r minus mg. Similarly, when the object during the rotation process, when the object is at the bottom, so when the object is at the bottom point, then we have Tb is equal to mv square by r plus mg. We can write like this. That means when you try to take the ratio of these two parameters, we have Tu by Tb, ratio of the parameters, is equal to, you can write down as V square minus Rg by V square plus Rg, we can write down. So in the examination, if examiner is asking us to find out, selected values are given, by using this particular formula, one can determine ratio of the tensions or the undetermined or untold velocity or V also be, you can apply using this particular relation. How you can find out velocity V using this? By applying component and dividendo, we can write down as what on V square by Rg is equal to, you can write down as what on simply Tb plus Ta by Tb minus Ta, we can write down. Now I need the value of what on velocity V. Therefore velocity with which it is moving in the system, that is given by, so square root of Rg into, simply you can write down as what, Tb plus Ta divided by Tb minus Ta, we can write down like this. Difference between the tensions to here and here, that means tension bottom minus tension at upper, the difference between them is equal to always 2 mg. So these are the two standard protocols what we have to be take care in the given case. So here at this location we are getting a low tension position and here we are getting high tension position. In the examination they can ask you like problems basing on Young's modulus of the particular wire or basing on the tension. They will ask you what is the elongation, Young's modulus, and what is the temperature rise. Different type of questions. What is the change in potential energy upon coming from here to here? What is the change in potential energy? Change in kinetic energy? Like that, different type of questions they can generate from this particular case. Let's see the concept of non-uniform motion. Under non-uniform motion, position to position, what happens? Velocity of the system changes and the tension also changes. So at this position, at an angular position of theta with the vertical, we got the tension T theta followed by velocity V theta in the given case. Now the topmost point is A and the bottommost point is B. Then at maximum means here, minimum means here, the possible values are given by like this. Since the speed of the particle is not uniform, therefore here in this particular case we need to consider the same speed here and here. But here different speeds must be maintained. That's why we got VA and as well as VB in the case. But for the more generalization process, what we have considered is nothing but a T minimum must be 0 at the starting point, the starting one. Then when you consider the velocity circle, in the entrance examination, directly you have to remember full circle completed, full vertical circle completed. In such a case, bottom speed should be root of 5Rg, root 3Rg, root Rg and root 3Rg. These are the minimum speeds. Minimum only we are just talking. Minimum means tension minimum must be 0. Under that condition only we have the velocity circle and we have the tension circle. That means in this particular case, the difference in the tensions, uppermost point to the bottommost point, the difference in the tensions must be is equal to what? 6 mg. This is the rule in this case, and here the rule is nothing but 2 mg in this particular condition. Now, suppose if the velocity is not maintained exactly these values, okay, then how do you consider in the non-uniform motion? Let us see in a short. Suppose in the given case, what happened if the speed is not exactly equal to root of gr at the topmost point, and if the speed increases at the topmost point, then what happened? Let the starting point contains a velocity root of ngr, and exactly at the bottom we have root of n plus 4 of gr will be there. Why and how? Because of these two principles. So tension at this particular position becomes mg of n plus 2 plus 3 cos theta, and velocity at that particular location becomes ngr plus 2 gr of 1 plus cos theta. My dear students, please try to remember only these two formulas. That is enough for now. Suppose if the particle is exactly at this location, means how many degrees is there? 90 degrees. Means cos 90, how much Rana? Cos 90, 0. Therefore, simply can write down as what Rana? ngr plus 2 gr. Therefore, at this particular location, you have speed of, say it is 90 degrees position. So this like this. At this condition, we can write down as root of ngr plus simply 2gr is there. So therefore, what is common in the problem? Gr is common. As a result, we can write down as n plus 2 into gr. Let us try to find out whether the given consideration is correct is not. So in this particular case, Nana, let n is equal to 1 you substitute in the equation. Upon substituting n is equal to 1 in the equation, root is gr, root of 5gr, root of 3gr, n is equal to 1 means. So this is satisfying our imaginary condition. Okay, right now. Now let us see in the next part. We will try to consider ratios. Okay, what we have to take care. So what is the ratio between topmost point to the bottommost point ratios? In this particular case, velocity at the point A to that of velocity at the point B. These velocities are exactly equal to root of ngr by n plus 4 gr. Therefore, you can write as n by n plus 4. By using this particular formula, one can determine ratio of the velocities. Let us see the next concept. How to find out the tension in this particular case. So, to find out the tensions at the different positions, use this logic. What is the logic, Nana? Substitute the value of theta is equal to first initially at B means take it 0. Cos 0 means what, Nana? 1. So, 3 plus 2 means what? 5. 5 plus. So, therefore, you can write down as TB in the given case is equal to n plus 5 into mg. We can write down like this. And what is the tension at this particular place? At this particular place, theta is equal to how many degrees, Rana? 180 degrees. Therefore, when you take see T at A, I need. So, when you try to plot like this, exactly the angle becomes here 180 degrees. So, when angle cos 180 here today, cos 180 value how much? It is minus 1. Therefore, 2 minus 1 means minus 1. Therefore, you can write down as n minus 1 into mg. We can write down. Now, in the given case, substitute the value of n is equal to 1 for our cross verification. N is equal to 1, substitute here. TA is 0 and TB value is equal to 1 plus 5, nothing but 6 mg, which is matching with the just previous slide. Okay, right. Anyways, now what is the ratio of the tensions here? So when we try to consider TA to that of TB, ratio of the tensions given by n minus 1 by, you can write as what? N plus 5. So in the entrance examination, they will give you VA by VB value and they will try to ask you what is the value of TA by TB value. That means, first of all, you have to find by using this formula, try to find out the value of n in the equation. Then after that, n has to be substituted in this particular case and try to work out for what TA and TB in that particular case. Okay, like this we have to solve the problem. See one or two applications over the vertical circular motion. When you consider application point of view, okay, now let us consider this is something like a convex bridge. Over the convex bridge, a vehicle is going on like this. Then what will happen? mg will act vertically downward direction. Normal reaction acts in the vertically upward direction. So that means this is the direction of a normal reaction we can take, and mg acts in this direction. Therefore, along the cos component or adjacent side we have mg cos theta in the figure. Now, so normal reaction acts upward, mg cos theta downward. In such a case, effective normal reaction acting on system n is equal to mg cos theta minus mv square by r. On the concave bridge, under such a condition, what we have to do? So when you try to consider like this, normal reaction L in the upward direction, mg cos theta acts in this direction, and the resultant value will be given when normal reaction is equal to mg cos theta plus mv square we can write down. How these equations came in this particular case, that is important thing. Shortcut to remember here is nothing but net force, centripetal force, net force is equal to, you have to take. Since the body should not leave the contact, that means which one has to dominate? Mg cos theta has to dominate. Like that you remember, Nana, that is very easy. So therefore, mg cos theta minus normal reaction. Then only the system will be stick on to the circular motion. Otherwise, not possible. So therefore, better to understand like this. Second condition. So in this particular case, in order to move in the vertical upward, in order to move in the upward direction, n should dominate compared to mg cos theta. Therefore, mv square by r, centripetal force must be is equal to n minus mg cos theta we have to take. So when you try to readjust the things, so upon solving this entire cases, we can find what are the normal reaction here and normal reaction here in this application. Next, application number, okay, see this is application number 2 and application number 3, application number 1. Right. Now, in this particular case, let us try to consider what? Something like a water-filled bucket allowed to rotate. Such a condition that in the vertical condition, the water should not fall down. That means it has to continue in the vertical circular motion, then only possible. That means the speed at the topmost point should be minimum low greater than or equal to what? Square root of Rg. But what is V? V is nothing but R omega only, na? Substitute the value of V is equal to R omega in the equation. And then upon solving, we will get time period T is equal to or less than or equal to 2 point root of R by G. That is the cos. Why? This is the cos. V should be greater than or equal to square root of Rg. V is equal to R omega. Further, from the rotatory motion, omega is equal to greater than as what? 2 pi by T. So, substitute here, you will get the correct answer for the problem. Okay, thank you. For example, this is the rigid support and we have a block having mass capital M and a small bullet having mass M with initial speed u moving and hits the block. And in this particular case, we have two situations. First situation is a full circle and second one is part of full circle. So we have the two situations. In the two situations, how to solve this particular puzzle? If the full circle is observed for the motion, then the combined speed should be is equal to root of how much, Rana? 5gr. Because at the bottom of the vertical circle, this is the speed. A part only there, it is not the full circle, only a small angular displacement is there. That means this is the initial position. Now this is the final position here. And angle between them will be how many degrees, Rana? Theta degrees. Then, in this particular case, to raise of this particular height, how much amount of thing will happen here? So therefore, you can write down as V is equal to root of, simply you can write down as 2gr cos theta. We can write down like this. So minus, what is the actual height? R is the actual height. So therefore, you can write down as simply 2gr of 1 minus cos theta. We can use this particular formula. By using this particular formula, one can determine what is the meaning of what? Length of the pendulum or radius of the circle. Everything you know standardly. This is called as combined speed during the collision process. That means, what is the full formula? So in this particular case, by applying law of conservation of linear momentum, mu plus m into 0 is equal to, because both, see the bullet get embedded into the system. That means they are mixed with each other. So m plus m into combined speed is nothing but what you can write as vcom. So therefore, the velocity required for the bullet in the case 1 for full rotation is equal to simply m plus m by small m of root of, you can write as 5gr. Like this one can determine. And in the second case, when the part of circular completes, under such a condition, applying law of conservation of linear momentum, mu plus capital M into 0 is equal to m plus m into root of 2gr of 1 minus cos theta. Just we have to do like this. Now I want to find out the velocity need for this particular projection. u is equal to simply m plus m by m into root of 2gr of 1 minus cos theta we can write down. So this is one more application. Say you can take it what? Application number. Now we would like to see the last application. Suppose in this particular case a block having mass m now starts from with velocity of v naught on the semi-spherical ball of having the total radius r. Upon traveling up to this particular point, this selected point is called as P. What happened? The block leaves the surface. So not only for this problem, when the system leaves out the surface, means what? Normal reaction n is equal to 0. That is the important thing. So when at n is equal to 0, means what? The block leaves the semi-spherical ball. So under such a condition, okay, what is happening here? So whatever the mg upon resolving, so centripetal force is nothing but mg cos theta is equal to mv square by square, we can write down. And here speed is v, here speed is v naught. Apply law of conservation of energy. Change in potential is nothing but h. So h you have to use here. H is nothing but r of m minus cos theta, already we know. Substitute here, solve me, go to the value of theta is equal cos inverse of, like this we got in the problem. Suppose in this examination, that person will try to ask us if it is continuing with the speed of root of gr. That means here you have to substitute root of gr. So different kind of problems will come into picture. Suppose in this particular case, case 1, suppose v naught is equal to root of gr. It starts with the root of gr. Then what happens? Then the theta is equal to, we can write down as cos inverse of gr both gets cancel, 1 by 3 plus, what do you write down? It is 2 by 3. That means what do you write down here? Cos inverse of 1 we can write down. Cos inverse of 1 means theta is equal to how many degrees, Rana? Theta is equal to 90 degrees. Means at 90 degrees exactly, the system will try to leave the surface. That's a condition. That means it will try to continue in the vertical circle. That is the internal meaning. That's it. Let us take case 2. Case 2 means what, Anna? Let VO is equal to 0. That means initial object starting from rest. Under such a condition, when I substitute VO is equal to 0, then theta is equal to, you can write down as simply cos inverse of, look here, Anna, this part is 0, then we can write down as 2 by 3. Now, this particular height is called what, Anna? Let us say y. So upon solving here, cos theta is equal to, you can write down as 2 by 3. What is cos theta in the problem? This is the radius r. Adjacent side by hypotenuse we can take. So this is the adjacent side, this is the opposite side, and this hypotenuse. Therefore y by r we can take, y by r. Therefore the system leaves the surface at a height of y is equal to 2r by 3. That means this particular y should be always equal to 2r by 3 when object starts from rest. Or if the object is starting from what, Anna? V is equal to root of rg, then you can take directly theta. It will try to continue in the vertical circular motion. Like this, in the examination, we can face some questions. Thank you.